So I did get exams graded. I know that it took me a while. I'm still working on getting projects. My goal is to have projects graded by the end of the week. I've had a work project going on that has taken a lot of my time, so I'm apologizing for being behind on those. So which also caused me to be behind on putting out this week's message. So again, I apologize. We're trying to get caught up. It's just that point in the semester, you know how that is. So if we look at our schedule, today I'm supposed to finish up 4E and teach 4F, so we should be able to do that. Tomorrow I'm going to go over quiz 5 during our extra session, and then I'm also going to go over the project. And I know, another project, are you kidding me? Oh goodness, somebody's being very naughty. Hold on. Okay, so the reason why the Unit 4 project is in the middle of the semester, in the middle of the unit, is because it is, you're going to use linear regression in Google Sheets to do the project. And so since we're just talking about that now, it's important for you to do it right away so that you don't waste time and lose the skills. There's not a homework assignment for 4E, which is again why we do the project right away. So I want you to think about the project, which is called the flight project, or the flight predictability project, as basically your homework for section 4E. So you've got, like I said, today you've got your quiz 5 due. Tomorrow I'm going to go over the problems from that quiz as well as the project. And then on Thursday, I'm going to get into 4G and 4H. So 4F, 4G, 4H, and 4I all have to do with solving systems of equations, but it's different ways that we solve those systems of equations. So 4F is solving systems of equations by graphing. And we're looking at how two lines would interact with each other. And then 4H, or excuse me, 4G and 4H are doing that with algebra, using algebra steps to solve those systems. And then 4I, I'm just talking about the rest of this unit. 4I is how we apply systems of equations to something like business, right? So just kind of give you an idea about how like we're sort of wrapping up this whole unit. But yeah, that's not really that important. We're going to focus first on 4E. As I said on when did we see each other last Thursday? Was it on Thursday? I was hoping that you would try that Green Mountain, the Keurig example number 2 on your own. If you didn't, that's okay. I'm going to talk about it still. And I'm going to take a moment, if we have time, to show you how to solve these with Desmos. I might not get to that today because I do want to make sure I have enough time to go over 4F today. So let's look at 4E number 2. So I'm going to share my screen. We're going to first go look at the notebook page, and then we'll get into the Google Sheet aspect. So as usual, do we have any questions though before I get started? I just want to make sure I put that out there before I jump in too much.
Nope.
Okay. So as we can see from the notebook page, it says the number of Keurig Green Mountain single-serve cup pods sold each year is shown in the following table. So in 2009, there was 1.94 billion cup pods sold, 2010, all the way down through 2014. And so it went from 1.94 billion up to 11.6 billion in 2014. I get that that's almost 10 years ago, but that's what I have the data for. So it says use Google Sheets to find a linear equation that can be used to predict the number n of cup pods in billions sold X years after 2009. So again, this piece is really important in terms of knowing what you need your X value to be. We're measuring it in years since 2009. So if we look at our table, we are going to think about creating a table in Google Sheets with column X and column N, where X is years since 2009. So we can think about that as in years since 2009. So if the year is 2009, that is 0 years since 2009, right? So 2010 is going to be 1, 2011 is 2, 2012 is 3, 2013 is 4, and 2014 is 5. Then N is your number of cup pods in billions. And we can just use those numbers as they are. We don't have to adjust those at all. Okay, so let this catch up. It's taking forever. There we go. So now we're going to split our screen and look at what it looks like in Google Sheets. So give me just a minute to set this all up. So we have everything on one screen. All right, so looking at our screen here, you can see I've already transferred my table. Let me blow this up just a little bit. So you can see here, we're taking this table here on our notepad, and we're transferring it to Google Sheets. So we've got the year since 2009, 0, 1, 2, 3, 4, 5, which I've transferred over here. And B is number of cup pods, right? And so our instructions say use Google Sheets to find a linear equation. So what this really means, this statement here means use linear regression. And we're using Google Sheets as the tool to calculate that linear regression. In your next class, you will be using Desmos. But for now, with what we're doing in this course, Google Sheets is fine. So remember, in order to use Google Sheets to do this linear regression, we first have to create the scatter plot, right? So if we think about our steps is plot your data as a scatter plot. Okay, so in order to plot our data, we're going to select both columns of data. We're going to go up to insert, and we're going to insert a chart. Now, because I have my window blown up, we can't see everything really nice, but you can see we've got our scatter plot chosen here under chart type. If it doesn't automatically come up with scatter plot, remember you can choose the drop-down menu and scroll down to what you want. We want a scatter plot because we are not looking at the time in between those 2 years yet. We're just saying these are our data points, so we want those to be discrete and have specific spots. So we've got that scatter plot, and then remember, in order to insert our trend line, we are going to go over here to customize, and you're going to go down to series. So insert trend line. You're going to go to series. And then after series, you're going to go down to trend line. All right, we're going to select that trend line. And then Under label, we're going to choose use equation. And that will give us our equation. So we're going to X out of this. Again, we can't see all these pieces because I have it blown up. But once I X out of the window in order to adjust our data, we can now see our graph. Okay, so you can see we've got the trend line moving through. Okay, so this looks relatively linear, and we have an equation that comes up. So our equation is n equals 2.01x plus 1.77. Now remember, when we're looking at the equations, we need to be able to identify what these pieces mean, okay? So this is in slope-intercept form, okay? This value here is my slope, and this value here is my y-intercept. So what I want you to do is I want you to think about what those two numbers could mean in terms of this problem. And I want you to send me your answers in a direct message. So what I mean is, what does that slope, what is that rate that the slope is representing? Okay, what does that 2.01 mean? And then the y-intercept of 1.77, what does that mean in terms of this problem? So you might want to look back at everything I wrote in problem one. Again, just think about what they could mean in terms of this problem and send me your answer in a direct message. So when I'm asking you to figure out what these slopes mean, I want you to think about how we would have identified the slope to begin with. The slope, remember, is going to be your change in cup pods. So the slope, you would have cup pods over years, right? So if we have cup pods over years, that means that if we have a slope of 2.01, that means that our number of cup pod sales is increasing by 2.01 billion cup pods per year. And we need to make sure we include that billion part because we're giving a measurement to what this is saying. So increase in 2.01 billion cup pods per year. And then our y-intercept is the on average initial value. And so sometimes this value will be weird in terms of the problem you're thinking about, because you might say to me, well, but Aaron, we already know what the initial amount of cup pods sold in 2009 was, right? It's 1.94. But we're finding the with linear regression, we're finding on average what's happening. And so the y-intercept of 1.77 is an average of how many cup pods would have been sold in 2009. So that y-intercept doesn't really match up with the data that we use, but that's what happens when you use a non-perfectly linear set of data, right? You're going to get, when you're doing linear regression, it's averaging that rate of change. And so it's going to say initially we sold 1.77 billion cup pods, okay? But you want to still be able to identify what that means. So we sold 1.7 billion cup pods in 2009. And right, you could say approximately. I know I'm fitting in a whole bunch of words here. But again, approximately, that's what we had. So I want you to try part B. It says estimate the number of cup pods sold in 2017. So if we're predicting in 2017, we want to use this model. Let's remember our model is n equals 2.01 times x plus 1.77. And we want to know how many were sold in 2017. So in order to do that, we first have to think about, okay, well, x is measuring years since 2009. So we'll take 2017 minus 2009, which is a difference of 8 years. Okay, so if we plug the 8 in for x, we're going to have 2.01 times 8. Oops, this is kind of messy. 2.01 times 8 plus 1.77. And I personally, when I plug this in, I get 17.85 billion pods. But one of the common answers I was getting was also 17.63. So if you sent that answer where, because it's close, what was what was your calculation?
I started at 2014 and I just added 3 years.
Oh, yeah. See, because our model is based off of X being in 2009 is our initial value. We
Uh-huh.
want to compare all future predictions to that starting year.
Okay.
Yeah.
That
Because if we were to do what you like, I understand what you're saying. If we plugged in 3 years to this, it would be 2.01 times 3 and added on 1.77. That's 7.8. And so 7.8 plus what would be 11.6 is I'm assuming what you did.
Yeah, I just multiplied 2.01 by 3 years and then added that to 11.6. So it
Hmm.
was 6.03 plus 11.6.
Okay. Yeah, so I can see where you can get over this up. Yeah, so you want to go all the way back and compare it to your starting value.
Okay,
Yeah,
makes sense.
yeah. So I did look up because I was curious. Keurig's crazy. So Keurig eventually got its name because the founders looked up the Dutch word for excellence. So that's what Keurig means, is excellence in Dutch.
Hmm.
And it was started in 1992, and it first started offering the K-Cup pods in 1998. But they were specifically targeting offices, like business offices, which makes sense. Like, you're not going to want to brew a whole cup of coffee. Like, people want to be able to go by and like brew their own cup pods. But they didn't even start marketing to homes, like to the standard US consumer, until 2004. And then Green Mountain Coffee Roasters invested in the company in 1993 and then formally acquired it in 2006. And I was just Googling it, and I guess Keurig now owns Dr. Pepper. Like, I, at some point that happened. And they, I guess in 2020, they added 3 million new US households. Like they sold Keurig machines to 3 million new US households, which I don't know how they track that, because honestly, like how do they tell the difference between, I guess it has to do with like people like registering warranties, but like who's not just like upgrading their machine, or if like their machine broke. Like I've had them break. I mean, I have one, we use it all the time, but I've had one break and we've had to buy a replacement, you know what I mean? So like
Yeah, how
I
do
don't
they
know how
know
the
it's a
market
new
research
house
works.
every time?
It's not my thing, but the total number of US households at the end of 2021 that supposedly use Keurigs are 36 million. I thought it was crazy. So yeah.
It's a lot.
Yeah. I don't know. I always find this stuff fascinating. Only because it's like so outside my own life and what I do. So, supposedly, and this is supposed to be by 2020, and I don't know if they actually met this mark, but when I did some research a few years ago, the company had planned to have 100% of their K-Cup pods be recyclable by 2020. But like, in order to recycle them, you have to like peel off the little top and empty out the grains. And then, like, as we know, what we believe gets recycled ends up in our landfill. So who knows where they're at with that one. Um, yeah. And supposedly in 2017, 29% of Americans were using them, which must be much higher now if 36 million households are using them. So, anyways, that is our little detour into cup pods and Keurig. So I'm not going to take the time today to go over and show you how to do linear regression in Desmos. I'm going to talk about that tomorrow. Today I want to use the remaining time to talk about 4F. which is graphing systems of equations. Okay, so before I leave this, are there any questions about linear regression in Google Sheets?
No, that makes sense.
Okay. So, wait, I don't think I have what I want in here. So, give me just a minute to pull in the notebook pages that I need. All right, so solving linear systems graphically. So a system of two linear equations can have three different types of solutions. We can have one solution, and this is where an ordered pair satisfies both equations. And when I say satisfy, it means that if I were to plug that ordered pair into both equations, it would make both statements true. And that ordered pair is where those two lines intersect. So this is that one solution. It's that point where those two lines overlap or intersect, however you want to say it. Then we can have the idea of no solution, and no solution happens when two lines are parallel. And so when we think about things that are parallel, right? Predominantly railroad tracks are parallel. Occasionally they cross over each other, but the two tracks are parallel, right? And two things are parallel when they have the same slope. So the no solution, when the lines are parallel, it means that the two equations or the two lines have the same slope. So an example of this would be something like y equals 2x plus 4 and y equals 2x minus 3. They both have the slope of 2, right? Because the 2 in front of the x, but they have different y-intercepts. And so these would be parallel lines. And then we have this last way that we can talk about them, which is that they can have an infinite number of solutions. And it's where one equation is a multiple of the other. And so their graphs are the same line. Now, if we think about ways that we can display these equations, right? We can have slope intercept, which is where y is isolated. We can also have standard form. So let's say I have x plus y equals 4. Well, a multiple of this equation would be something like 3x plus 3y equals 12. Now, all I did is I took that first equation, x plus y equals 4. I multiplied the whole thing by 3. And multiplying by 3 made a new equation, but it's still the same as the original one. It's just a multiple, okay? So if I were to graph those two graphs would end up on top of each other, and they would have an infinite number of common solutions because they're really the same line. So we can classify these systems and equations based on their solutions. So a consistent system, when I say system, I'm talking about the two equations that make up the system. A consistent system has at least one solution, and this would be a system of lines that intersect at one point or would be considered the same line with that infinite number of solutions situation, versus the idea of an inconsistent system, which is where it has no solution, and this would be that system of parallel lines. Two equations can be considered dependent if one can be obtained by the other by multiplying by a non-zero constant. Again, the graphs of graphs of dependent equations would be one line. So the example for these dependent would be these two up here, right? X plus y equals 4 and 3x plus 3y equals 12, right? One is a multiple of the other. Then two equations are independent if one cannot be obtained by multiplying the other by a non-zero constant. The graph of independent equations would be two lines that intersect at one point or are two parallel lines, okay? So in your homework, they do ask you to identify if they are, how do they put it? You'll have to say if a system is inconsistent or consistent, and if the system has one solution or multiple solutions or something along those lines, okay? So that's why I use that language here. So we're going to practice. We have two equations. We have negative x plus y equals -4 and 3x plus y equals 1. So remember, there's multiple ways we can graph these lines. If you like to generate ordered pairs for each line and graph it that way, that's fine. If you like to put them in slope-intercept form, which is usually what I tend to do, you can do it that way. So however you choose to do this, we need to graph these two lines. So I'm going to do my first one in green. If I take my equation, -2x plus y equals -4, and I isolate y, that means I'm going to add that 2x to both sides, giving me y equals 2x minus 4. Now, if I identify, what do I have? What information do I have here? Well, I know that my slope is the 0.2 over, or not the point, excuse me, it's the ratio 2 over 1, okay? And then my y-intercept, this is the point. And if it's -4, that means my y-intercept is the point 0, -4. So I can start by graphing that point, right? That's how we graph our lines. We always have to start with a point. So going to 0, -4 is going to be this point right here. And then I'm going to use my slope of 2 over 1, which remember that means go up to, right 1. Go to my next point. And I can create, if I keep going with those dots, I can create a nice line that I can then follow. And I can see there is my first line, okay? So once we have that one graphed, then we can graph our next one. I'm going to graph this one in blue, just so we have opposite colors. Again, I'm just going to isolate my y variable here by subtracting 3x from both sides. Isolating this allows me to put this equation in slope-intercept form. Again, how did I isolate that? I subtracted 3x from both sides. So in this new equation, what information do I have? Well, we know that the slope is the ratio of -3 over 1. The y-intercept is the point 0, +1. Again, I know it's +1 because it's y equals -3x plus 1. So we're going to start by graphing that point, 0, 1. We'll use our slope of -3 over 1 to get to my next point. So I'm going to go down 3. Over 1. And I can see I already have that spot overlapping there, right? You can see where I put the blue dot on the green line. That's my solution. So, oops, looks like I got out of order some of these. Let's see, yeah, 1, 2, 3 over 1. There we go. And so now I have two lines. Because these two lines intersect at one point, I can see that intersection right here, okay? So we can say that we have a solution. The solution to this system is the point 1, -2, right? We can identify that ordered pair. We'd have to go to 1 and then down to -2. We can say that the system is consistent because there is a solution, but that the equations are independent. Dependent. Okay. And again, the reason we know they're independent is because one is not a multiple of the other. And when I graph them, I don't get a single line as my solution. All right, so we're going to go to the next page. I'm going to have you do the next one on your own. Just so you know, there will be a solution here. So number one, I want you to do that one there. You're going to tell me what the solution is, right? So you're going to say what the solution is. Solution, let's spell properly. And then you're going to decide, what can you tell me about the system? Is it consistent or inconsistent? And then you're going to tell me about the equations. You're going to tell me, are the equations independent or dependent? Okay. So those are the 3 pieces of information you're going to send me. Okay, so if we graph this, like I said, I like to isolate my y variables. So I'm gonna have y equals negative x plus 5. In this first equation, my slope is gonna be -1. So it's gonna be -1 over +1. My y-intercept is gonna be the 0.05. So graphing that, we're gonna 0 up to 5, down 1, right 1, gives us all of these lovely points and a nice line. And we can draw our line. Okay. For the second equation, I'm gonna choose a new color. And that's already in slope intercept form. So we don't really have to do anything there. We do know that we have a slope of 2 over 1 and a y-intercept of 0, 2. Graphing that. Again, we always start with that y-intercept up to right 1. And we can already see as I'm graphing these that I already plotted that point. Okay. And there is my solution. So because I have a single solution, I know the solution is the 0.14. Okay. The system, because there is a solution, is consistent. But because we have two lines, the equations are independent. So what does it look like if we don't have a solution? Okay, so I'm giving you that hint, I'm giving it away for number 2. We already have that situation here. So like I said, we can isolate our y variables. So if I take this first equation, I have 1/2 x minus y equals 4. I'm going to subtract 1/2 x from both sides, giving me negative y equals negative 1/2 x plus 4. We have a negative y. I don't want a negative y, I want a positive y. So I'm going to divide everything by -1. What this does is it changes that negative 1/2 to a positive 1/2, and it changes the plus 4 now to a -4. So pulling out our important information, we know that we have a y-intercept of -4, a slope of 1/2, so up 1, right 2. And that shows us our line. Okay. And if we look at our second equation, bring that one down, I have x minus 2y equals -8. So we're going to subtract x, giving negative 2y equals negative x minus 8. We're going to divide by -2 on all 3 terms. Make this 2 a little nicer. Oh, I'm way ahead of where my board is showing. Hold on one second. Let me wait for this to catch up. This equal sign was weird. Okay, so when I have negative x divided by -2, remember there is that negative x is the -1x. So I'm dividing it by -2, those cancel, giving me a positive 1/2 x. We always want to imagine that when we have a variable by itself, it has a coefficient of 1, okay? So when I'm doing that negative x divided by -2, that's really -1x divided by -2, which is how I come up with that 1/2. Then when I take -8 and divide it by -2, I'm going to get a plus 4. So we were really close to this being like an exact copy of each other, but the one thing that's different is those y-intercepts. And so we're going to go and graph this line. Instead of having a -4 for its y-intercept, the first equation, it has a positive 4. but they both have that same slope. So you'll notice that when I graph this, again, these lines are parallel and they're never going to intersect. And so because they're parallel, they're never going to intersect. That means that we have no solution. So there's same slopes. So what I want you to think about is that they have same slopes, which tells us they are parallel lines, which leads us to the conclusion that there is no solution for this system. And when we talk about the system, because there's no solution, we would say that the system is inconsistent. But because there still exists two lines, the equations are still independent. So far we've looked at, we can have one solution, we can have no solutions, and then the last one I want to look at is what happens when we have infinite solutions. Okay. So again, very leading like suggestion. Of course, we're going to have something that comes up weird. Looking at number 3, I want you to write both of those equations in slope-intercept form, and I want you to send me your answer in a direct message. So in number 3, I want you to isolate y, is really what I'm asking you to do. So isolate y for both of those equations and send me your answer. If we look at isolating y in this first equation, we have 2x plus 4y equals 12. Subtracting 2x from both sides, we get 4y equals negative 2x plus 12. Dividing all three terms by 4, we're going to get y equals negative 1/2 x plus 3. So if we graph that line, oh, let me wait for my board to catch up. So graphing that line, we're going to have a y-intercept of positive 3. So right here, a slope of negative 1/2. So down 1, right 2. So go ahead and we graph that line. Oops. Okay, so there's our line. If we look at the second equation, we've got that 4x plus 8y equals 24. We're going to subtract the 4x from both sides, giving us 8y equals negative 4x plus 24. Dividing everything by 8, we get y equals negative 1 half x plus 3. So we get the exact same equation. I'm not going to bother to graph it again because we can see we have the same equation. So because it's the same equation, this tells us that we have infinite solutions. Now, in my math lab, the way that they write this is in order to say that we have infinite number of solutions, they use set notation. So this is going back to kind of what we talked about in unit 3. And we would say that it's the set of all ordered pairs x, y, such that, and I'm not expecting you to be able to write this yourself. I just want you to be able to recognize, because it's going to give it as one of the options for an infinite number of solutions. And so I don't want you to be thrown off by this notation. So it's the set of ordered pairs x, y such that they lie on the line. So they would write y equals negative 1 half x plus 3. And so in mathematical notation, what they're saying is that it's all the ordered pairs x and y that are on that line or satisfy that equation. That's what that solution means. Now, when we talk about the system of equations, the system is consistent because we have at least one solution. So the system is consistent, but with the equations, because they're the same one, we can say that one is a multiple of the other one, and therefore they are dependent. And what do I mean by one's a multiple? If we look at these first two equations from the very beginning, I could have taken that first equation, 2x plus 4y equals 12, and multiplied the whole thing by 2, and I would have gotten that second equation, right? I would have gotten 4x plus 8y equals 24. So one is a multiple of the other because they're the same line, and so again, these equations are dependent of each other. All right. Our last one that we're going to do together is number 4. Actually, I lied. It's not the last one. We're going to go to the next page. Let's look at number 6. Okay, and we'll go back to that other one. I want to talk about number 6 before I let you go. We have about 15-20 minutes left. So what do we do when we see something like this, right? Number 6 says x equals 3, y equals negative 2. What do these even mean? Well, remember, when we have equations in the form of just x equals something, this is the format for a vertical line. Okay, vertical lines are where every single point on that line, x is equal to 3. If we were to go into Desmos, let me show you what I'm talking about. Let me pull this over. One second to reshare my screen with you. Okay, so if I go into Desmos and I take this and I graph it, I'm just going to say x equals 3. I can see that that line shows up here, right? That's that red line. And it's showing me what my y-intercept is. It's the 0.30. So that's not the y-intercept. What am I talking about? That's the x-intercept. It crosses the x-axis there. So if I graph that line, it is a vertical line right here. Okay. Then y equals negative 2 is a horizontal line. Okay. Horizontal line. Every single y coordinate is negative 2. So if I go to y equals negative 2, which is right here, I can graph that line, right? This is the point where y equals -2. So if we go to Desmos and we say, all right, well, y equals -2. We can see where those two equations interact or intercept, okay? When I'm looking at this blue line, it does give me 2 points. It gives me the y-intercept, which is at 0, -2, and then it gives me the point here, 3, -2. That is the solution to that set because you have your vertical line where every x coordinate is 3, your horizontal line where every y coordinate is -2. So of course they're going to intersect at the point where x is 3 and y is -2. So they have a solution. This system has a solution. It's right here, right? So that has a solution. And it's the point 3, -2, okay? And so we would still say that the system is consistent because there is a solution. And these equations are independent. And yes, these are equations. Okay. So if you are struggling to visualize it, graph it in Desmos. It's always going to be helpful. Okay. So going backwards, now that I got that piece done, we're going to end class with going backwards to number 4. So I've got that displayed. I want you to graph this system, identify if it has a solution, and send me your answers to, as we've done, what's the solution, if there is one? Is it, what can you tell me about the systems? And what can you tell me about the equations? So what can you tell me about the system, right? It's not plural. So just like we've done for the last couple ones, find the solution, tell me about the system, tell me about the equations.
Number 4, correct?
I'm sorry, what?
Number 4?
Yeah.
Okay.
Okay, so I'm not gonna bother to put these in slope-intercept form. I just want to show you something about how powerful Desmos is. So if I take these two and I graph them. So my first equation, I'm going to graph here in 2x plus y equals 10. There's my first equation, right? It's giving me those two ordered pairs. Okay. What do we know about these ordered pairs? Well, these are the x and y intercepts, right? Our second equation is going to be negative 2x, negative 2x plus 3y equals 6. And you can again see we've got, it tells me what my two intercepts are, but then it also tells me where these two lines intersect. And these lines intersect at the point 3, 4. So there's the solution. Which is 3, 4, which tells us that this is a consistent system. And that the equations are independent. Now, when you are completing your quiz, I know that a lot of this stuff, you're like, when you're graphing the lines, I get the thing all the time, like, well, Erin, what am I supposed to do to show my work? Like, literally draw your graph on your piece of paper. So I know what you're trying to do, because if you accidentally mess up when you're graphing with the tool, I know what you meant, okay? So just because you're using this technology does not replace the fact that you need to actually like write it down, show me what your thoughts are, what you had meant to graph. So make sure when you are submitting your written work for this quiz, you show everything. Okay. So tomorrow, like I said, I'm going to go over the most commonly missed questions from the quiz that's due today. I'm gonna go over how to do linear regression in Desmos, and I'm gonna go over the project. It's the flight predictability project. So I encourage you to take some time to look over that before lecture tomorrow. But that is what I'm doing tomorrow. And then on Thursday, we will pick up with 4G and 4H. So any questions for me before I let you go? All right. Well, happy Halloween. You're like me, you're gonna just eat a lot of candy and not get any trick-or-treaters, which is most likely what's gonna happen at my house. My husband was like, let's get the Costco bag. And I was like, we're not gonna get anybody. He's like, sure we will. We're not gonna get anybody. We're gonna eat candy for 3 days. But anyways, it's not bad, right? All right, everyone, have a great day. I hope to see you tomorrow. And if I don't see you tomorrow, then remember you got to do your time in the FMC. Those are your two options. So have a good one. And if I don't see you tomorrow, I'll for sure see you on Thursday.
Thank you. Halloween.